Hello, mathematicians of the internet. Today's problem, distance between parallel lines. And this is a tough problem because there's kind of several subroutines that are kind of within the problem. And so it's also a great problem because it puts a lot of skills that you learned in algebra together and jogs your memory. So I have two parallel lines here, well, one set of parallel lines. And the red and blue lines are parallel, and we know they're parallel because when we look at their equations, the slopes are the same. It means the same steepness everywhere on the line, okay? Up to over 1 is the steepness. Now, I've drawn in a green line, and the green line is perpendicular to the other two. And I've drawn that so we can find the distance between these 2 points, all right? Now, we have one point, 0, 2, and we need to find the other point, all right? In order to find the other point, we have to do a system of equations. So a system of equations is just finding out where lines cross, all right? What lines do we need to find out where they cross? What colors here? Blue and green. We don't have that point, so those are the lines we need to find. In order to find those lines, we have to have an equation for the green line. And you may recall, here's note 1, that the slopes of parallel lines and perpendicular lines are related. So if the red and blue lines have a slope of a over b, then the slope of the green line is going to be negative b over a. So if I make this, a fraction, 2 over 1, and I flip it over, I get y equals negative 1 over 2 x plus 2. So I drew it through there, so it crosses at 2. That's the y-intercept. All right, so we have all the equations we need. We're going to set the blue equation here, 2x minus 3, and we're going to set that equal to the green equation, which is negative 1/2 x plus 2. All right, now I want to just take a minute to describe why systems of equations works so well. When we consider just the equation of a line, okay, let's take this line here, okay? If we consider this blue line, the slope is 2, that's the steepness. The y-intercept is negative 3, that's where it crosses. The x and y, some people never really understand what those are, but the x is the entire domain of the blue line. So it's how far the blue line spreads left to right. The y value is the range, so it's all the heights of the blue line, so how far it spreads up and down. So those are every point on the line, on the blue line. Now, when we're solving a system of equations, we don't care about every point. All we care about is this one point. And that's the point where the blue line and the green line are the same. That's the point that they share. So the x value here, this value here, is the same for both lines. And the y value, which is the height, is the same for both lines. So that means if these two y's are the same, then the two right sides have to be the same too. And we're solving for a common x value, okay, which is going to be this value here for that point. So it's important to understand the background of why systems of equations actually works, is because that one point is where the lines are actually the same. That's what they share. Now to solve this algebraically, there's lots of things you could do here. You could add 1/2 x to both sides, and then add 3 to both sides, get the x to one side, which is what I'll do as well. But I like to do this, and I'll show you why. 2 times 2x is 4x. 2 times negative 3 is negative 6. And then 2 times a negative 1/2. Think of 2 halves of a pizza make a whole pizza. So 2 times negative 1/2 is negative 1x. And 2 times 2 is 4. Okay? Notice that I don't have any fractions, and it's maybe easier to get the x's on one side and the values on the other side, or the constants, because I'm not working with partial numbers here. So I'm going to add x to both sides, and that gives me 5x. And then I'm going to add 6 to both sides, and that gives me 5x equals 10. And I know you've done this a million times. make a ghost 1 here, because 5 over 5 is just 1x, and then x equals 2. Okay, and so x equals 2, and remember, this is the x only at where these lines are touching, where they equal each other, so we know that they equal each other at now x of 2. So if x is 2, I can plug it back in either the blue or green line, okay, because remember they're the same, right there at that point, they're the same line, and the x is the same. So I can plug it in here, okay, which would be 2 times negative 1/2, or I can plug it in here, which is 2 times 2 is 4, that might be easier, 4 take away 3 is 1. So the height is 1, that's 1, and this value is 2 for both lines. Okay, and now we can run the distance formula. I'm going to make some space. Notice, by the way, how we did substitution twice. We set these equal to each other, which is substitution, and then when we found x, we subbed that back in to find y. So we did like a 2 substitution step. All right, so now distance formula. D squared equals, that's, the distance formula is written down there. Okay. Distance formula. So I've written it like the Pythagorean theorem because that's what it's based on, is like a squared plus b squared equals c squared. Except the a squared here is just the difference of the x values for the points, and the b squared is the difference of y values for the points. You'll see a lot of books sometimes put like a little 2 subscript and a little 1 subscript, and I'll show you why here. That's I'm going to write the 2 points, 0, 2, that, and 2, 1. That guy. Now, I'm going to subtract the 2 x's. I'm going to subtract down for these. 0 take away 2 squared. And then subtract down for the y's. 2 take away 1. Okay, and so side note, remember I mentioned these? That's just so that you don't subtract for x's in the down direction and then subtract up for y's. If you subtract down, you have to subtract down. It would have worked also if I subtracted up first and then subtracted up for the y's. Just make sure you keep your direction of subtraction consistent. Then if you just keep that in mind, you don't really have to have these subscript numbers. You just subtract the x's like I did, subtract the y's like I did, in the same direction. This would be negative 2 squared, which is 4. This would be 2 take away 1 is 1 squared, which is 1. So we have d squared equals 5. And to solve for d, we take the square root of both sides. But remember, usually when we take the square root of both sides, we have a plus or minus value, right? But since a distance can't be negative, can't have a negative distance, then we only really take the positive value. And so the distance here is root 5. Ta-da! Common errors I see are people don't know where to draw the line. Like, for example, if I drew the line here, okay, what's the problem with this? Well, the line is itself okay. You know, this might be perpendicular, and you could find an equation for it probably, but now there's 2 unknown points. And so you have to draw, I mean, you don't have to, but it's easiest to draw the line through a point you already know. So either you draw it through here, like this, because then at least you know one point is 0, -3. You know, so that would be much easier. Also, it's easier to write that equation because you know where the y-intercept is already because you drew it through that point. Or draw it up here where I did through this point here is 0, 2, and then it's much easier to solve the problem, much easier to find this equation and wrap things up. Another kind of thing I see happen is when they have this and I ask for the distance, some people just count down. The distance is 1, 2, 3, 4, 5. That is a distance between the lines, But the problem is like, that's not the shortest distance. And when we say distance between parallel lines, we really do mean, what's the shortest distance? What's, that's here, 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 and here. Not like if I go from here to, down here. And some people try to draw it like this, for example. I saw that on the quiz, where they drew it, but it's not perpendicular, and so it's a little bit longer than this distance here. Okay, so that's common error number one. Another error I see is once you have like this drawing up, and you have maybe this line here that you've drawn in, people will set the wrong equations equal to each other. So like they'll set maybe this right here equal to this right here. The problem with that is that if you set those two equal to each other, does the red line ever touch the blue line? They're never equal to each other. They don't cross, and so that doesn't work out. Some people will set like this green line here equal to the red line. That actually will work out, but it'll give you the point you already know. Because we already know where the red and green line cross. So solving system equations with the red and green line just gives you something that's pretty obvious already. So of course the correct decision here is to find out where the blue and green line cross, because that's the point we don't know. Another issue that I see is in the distance formula, people not adding the same or subtracting the same direction. So like if I have, let me see, I think this ended up being 2, 1, right? If some people go 0 take away 2 or 2 take away 0, let's say if we did this 2 take away 0 here. Then they're like, I can go 2 take away 1 for y's. So the problem with that is when you did 2 take away 0, and then, so which is, this would be 0.2 take away 0.1, but then you did 2 take away 1, which is 0.1 take away 0.2, and so you're going to get your values swapped there. So if you go 2 take away 0, you have to go 1 take away 2. Or, it would also be as valid, if you did 0 take away 2, you then have to do 2 take away 1. So you have to subtract in the same direction for the points. And those are the most common errors. How long was it?